Hello everyone, my name is Kirti Jare. I am a third year computer engineering student from MIT Academy of Engineering. In my exploratory data analytics subject, I am going to explain about the optimization of loss function and waste fit line using gradient descent. So first in introduction to regression. Regression is a type of a supervised machine learning used to predict a continuous value based on input data. Regression is a statistical technique. It is used to model and analyze relationship between variables. It helps in prediction of continuous values such as price, temperature, or demand. So the main goal of regression is to find a line that best represents the relationship between input X and output Y. For example, if we want to predict the house prices based on the size of house, so we are taking input X as the size and output Y as price in dollars. So we are trying to find a function that relates area to price. So this is the equation of best fit line y equals to mx plus c, where y is the predicted value, x is the input variable, m is the slope of line, c is the intercept on y-axis. The main aim of this regression is to find the best m and c values that minimizes prediction error. If we, for example, if we predict house price 5,000 into area, so next is the understanding error and loss function. To measure total error, we use loss function. Each prediction produces an error where error is equals to difference between the actual and predicted value. In linear regression, most common loss function is mean squared error. It calculates the average of square differences between predicted and actual values, where the smaller the loss, the better the model. Machine learning, a loss function measures how well a model is performing. It calculates the difference between the predicted values and the actual values. The goal is to minimize the difference, which means improving the accuracy of a model. For example, predicting the house price, actual price is 2,50,000 and predicted price is 2,70,000. So the loss will be the difference of actual price and predicted price will be 20,000. So, why there is a need for optimization? As the random values of M and C will create the large loss. We need to adjust parameters so loss becomes minimum. The optimization is equals to process of minimizing loss. Without optimization, prediction stays inaccurate. It helps model learn from data and make accurate predictions. Gradient descent. Gradient descent is an optimization algorithm used to calculate the minimum loss. It is like finding the bottom of a hill. The gradient is the slope of a loss function. Gradient descent moves in the opposite direction of the slope to find minimum point. Uh, it starts from a random point on the loss curve, calculates slope, then move opposite to the slope. Repeat until reaching minimum loss. It works by iteratively updating model parameters. It moves step by step in direction of the minimum loss. So this is the mathematical working of a gradient descent. These are the equations of gradient descent. If the alpha is the learning rate, and these are the partial derivatives showing how loss changes with respect to m and c. For example, we have taken here two arrays. Is x is the size of house and y is the price of a house. Mm, let m equals to 0 and c equals to 0. Let L be our learning rate. It could be a small value like 0.01 for good accuracy. Learning rate gives the rate of speed where the gradient moves during gradient descent. Setting it too high would make your path unstable. Too low would make convergence slow. So put it to zero means a model learning anything from the gradients. Calculate the Then calculate the partial derivatives of the cost function with respect to m. Let partial derivatives of the cost function with respect to m be dm. With little change in m, how much cost function changes? Gradient descent algorithm gives optimum values of m and c of the linear regression equation. With these values of m and c, we will get the equation of the best fit line and ready to make predictions. With each iteration, gradient descent adjusts the model's parameters to reduce the error. The learning rate controls how big a step we took. Too big can overshoot the minimum, too small make convergence slow. The process continues until the loss is minimized. So, the conclusion is gradient descent is a cornerstone of machine learning. Understanding it helps us train better models efficiently. Regression builds predictive models. Loss function measures model accuracy. Gradient descent minimizes error. So, the best fit line gives the accurate prediction. Thank you.